This video will cover some Unit 5 topics, and if you remember, Unit 5 is quadratics. So we're going to be talking about quadratic formula, completing the square, some circle stuff, quadratic linear systems, and linear circle systems. So if you flip open to your review packet that's in front of you, then we'll get started. Alright, so we're looking at the quarter 3 recovery, and we're going to start with the circled problems. On this first page, there are no circled problems, so we're going to flip it over. That doesn't mean that you don't have to do these ones, or that you shouldn't, or try them if you need more practice, but we're going to start with the circled problems, and then if you need more practice, you can always come back to the other ones. Okay, so we're going to start with example 3. It says solve for the roots of each quadratic. Express your answer in simplest radical form. You can see there were other directions before this, but we won't worry about rounding. We're just going to work on simplest radical form. Something that I forgot to include in these packets was the quadratic formula, which will be given to you on your exam, as well as your assessment after we get through the review. Quadratic formula looks like this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And if you're a student of mine, then you've heard me sing that a million times to the tune of Pop Goes the Weasel. I used to do that a lot with my students because you had to memorize it. However, it is provided on the reference sheet now. But if you want to hear it, then just come see me. I'll sing it to you. Don't worry. So first things first with example 3, it says we have 6x equals 3x squared minus 4. In order to use the quadratic formula, we have to have our equation equal to 0. And we always try to keep the x squared positive. So it looks like I'm going to move this 6x to the other side by subtraction. So now we have 0 equals 3x squared. And when you write your new equation here, we're going to order it in standard form. So x squared, then the x term, so minus 6x, and then the linear term, or the constant term, sorry, with no x in it. So from here, we label as A, B, and C. A is always attached with the x squared, B is always attached with the linear term, the x, and C is that constant. You don't want to plug in x's into your quadratic formula, but you do want to keep the signs the way that they are. So I always calculate b squared minus 4ac first. So we have negative 6 parentheses squared minus 4 times 3 times negative 4. And again, this is b squared minus 4 times a times c. Notice that I put the negative 6 in parentheses before I squared it. That's because if I don't put the parentheses, I'm going to get the wrong value. So now what we're going to do is type this entire thing into the calculator, just the way that it is, parentheses and all. And we end up getting equals 84. So now we're going to plug into the whole thing. X equals negative b, so we have negative 6 plus or minus square root of that thing that we just calculated. 84 all over 2 times a, which is 3. So now we just start simplifying. X equals double negative turns to positive, plus or minus. We do have to write our answer in simplest radical form, so what we're going to do is take the 84 and break it down into a perfect square and a non-perfect square. Remember that your perfect squares come from the list that you create by taking a number and squaring it. 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, so on and so forth. Then you go backwards, you take 84, you divide it by 25. It's not a nice number. Take 84 divided by 16, not nice. Divided by 9, not nice. But we do get a nice number when we divide by 4. 84 divided by 4 leaves us with a 21. And then it's still all over 6. So then we keep going. We're going to simplify as much as possible. 6 plus or minus square root 4 turns into a 2. Square root 21 all over 6. We're still not in simplest form though, because if I take a look at the numbers on the outside, they can all be divided by 2. So we have x equals 3 plus or minus 1 square root 21 all over 3. Now, even if this inside number, the 21, in the radical could have been divided by 2, we wouldn't divide it because it's stuck inside the radical, so we have to leave it by itself. All right, we're going to look at example or problem number 4 now. Very, very similar. Start by identifying your a, b, and c. Once you identify them, I want you to plug into the b squared minus 4ac. I'm going to do it here on the video silently without saying anything so that you have a chance to try it on your own. Okay, so I found b squared minus 4ac to be 76. So now we start plugging into the big quadratic formula. X equals negative b, my b was negative 2, so negative negative 2, plus or minus square root b squared minus 4ac, which we calculated to be 76, all over 2 times 6, 2a. Now again, double negative, as we saw last time, turns to positive, so we have 2 plus or minus radical radical, because we're going to break down 76. Take a minute to do that by yourself, and then we'll talk about how to move forward. If you need more time, pause the video. If not, stick with me. I found the largest perfect square to be 4. So I have 4 times 19 gives me 76. And then over 2 times a, which is 2 times 6, giving us a value of 12. So we have x equals 2 plus or minus. Remember, we're simplifying now, so square root 4 turns into a 2. Square root 19 stays all over 12. Except remember that we're trying to simplify as much as we possibly can. So take a look at the numbers on the outside of your radical and see what they can be divided by. So in this case, we have divided by 2. So we have x equals 1 plus or minus 1 radical 19 all over 6. And you can leave it just like that because it says simplest radical form, and that's exactly what we did. All right, flip it over so we can talk about completing the square. Another method for solving quadratics is called completing the square. And in order to do this, we have to make a perfect square as far as trinomials go. So what we do is we start by moving the constant term to the other side of the equals. So in this case, the constant is this minus 5, so we're going to add it to both sides. And as we rewrite, we're going to put a plus blank in our equation. X squared minus 6x plus blank equals 5 plus blank. We have to do it to both sides because whatever you do to one side, you must do to the other. Now we're going to calculate the value that goes in these plus blanks, and it's actually the same value for both of them. So what we do is take the linear term, the negative 6, we cut it in half, and then we square it. That's the process of completing the square. Cut it in half and then square it. So negative 6 divided by 2 is 3, negative 3. Negative 3 squared is positive 9. Remember, negative 3 times negative 3, double negative turns positive. So what we do now is we factor the left-hand side by using add multiply. So we set up our parentheses, we're thinking of numbers that multiply to 9 and add to negative 6. So our pair here is going to be 3 and 3. And because I'm adding to a negative but multiplying to a positive, my signs have to match. And because it's a negative, we have both of them as negatives. Equals 5 plus 9, which is 14. But now on the left-hand side, we wrote something out twice. We wrote that binomial x minus 3 out twice. So this can be condensed as x minus 3 parentheses squared equals 14. So now from here, our goal is to solve for x. So what we do is we take the square root of both sides, undo the squaring, and on the right-hand side, we do have to get a plus or minus in there, kind of like that quadratic formula we were just using. X equals negative b plus or minus, blah, blah. So now on the left-hand side, the square and the square root cancel, which was the whole purpose, equals plus or minus square root 14. And again, our goal is to get x by itself. So we have to add 3 to both sides, move it away, and we get x equals 3 plus or minus square root 14, which is choice A. So again, I know that it seems a little lengthy, but the main process is that first you move the constant, then you put your plus blanks and you find the value by taking your b, dividing it by 2, and then squaring. Then you just go through the process of simplifying by solving for x. We're going to take a look at number 8 down here at the bottom. We have x squared equals 4x plus 9. So remember, just like the quadratic equation, we want to get, or quadratic formula, we want to get this equal to 0. So I'm going to subtract 4x. We're going to subtract 9 from both sides. So now we have x squared minus 4x minus 9 equals 0. From here, we're going to actually move the constant term to the other side. So you could have, technically, kept the 9 on the other side. Remember, as we rewrite, though, we need to get those plus blanks in there. We find the value of the blank by taking the linear term, dividing it in half, and then squaring. Remember that it's always positive, no matter what. So now we are going to factor by add, multiply. So we're adding to 4, multiplying to negative 4. That means that we're using 2's, and because we're adding to a negative, we keep both of them negative. And 9 plus 4 on the right-hand side gives us 13. But now we have to actually solve for x, so what we're going to do is condense. We have x minus 2, parentheses squared, because we wrote it twice, we multiplied it by itself, equals 13. To get rid of squaring, we square root. And on the right-hand side, we get a plus or minus in there. So we have x minus 2 equals plus or minus square root 13. Then we're going to add 2 to both sides. So we have x equals 2 plus or minus square root 13. Now, of course, if this is a short answer question on your quiz or assessment or whatever it is that you're taking, sometimes you have to break down the radical a little bit further. In the 2 cases that we've seen, we have not had to break them down. However, sometimes, like I said, you do. So final answer, we should have choice D. Go ahead and flip it so we can start talking about some circles. We're going to flip it actually a couple pages, I believe, until you see the next circled problem. No pun intended, circled problem. Okay, so we are taking a look at circles with question number 15. It says, which is the equation of a circle whose center is the origin? Remember, the origin is 0, 0, and the radius is 4. If you look at your study guide, it tells you a couple different things about circles. We have the basic formula x minus h, parentheses squared, plus y minus k, parentheses squared, equals radius squared, where h, comma k is the center, and r is the radius. So if my center is at the origin, that means I'm replacing h and k with 0 and 0. So that means we now have x minus 0 squared plus y minus 0 squared equals radius squared. So I take 4 and I square it to give me 16. But if I subtract nothing, if I subtract 0, that's the same as x squared. And y squared equals 16. Choice B. The next one says, which is the equation of a circle whose center is 5, -2, and radius is 7? If we take a look back at that generic circle equation, we have a minus h in here and a minus k in here, but initially h and k were positive, so what you can see that's happening here is that we have to switch the signs. So if I start with a positive, it now becomes negative in the equation, which means that this positive 5 needs to switch to a negative, so I get rid of choice B and D. Now this the -2 changes to positive, so we have x minus 5 squared plus y plus 2 squared equals, remember this is the spot for radius squared. The radius is 7, so this is really 7 squared, which gives us 49. Choice A. For question 18 and 19, both of them say graph the circle. So here's my equation and we have to graph it. What we do is we start by finding the center and the radius. So the center of this equation, remember, is the opposite sign. So that -1 and -3 change. They become +1, +3. And then we also have equals 4. So this, remember, is r squared. So we have to take the square root of 4, which is 2. So we start by going over 1 up 3 to plot the center. And because the radius is 2, we go outwards 2 in all directions from the center of the circle. And then you just simply connect. Go ahead and try to identify the center and the radius of the next circle. The -3 turns positive, the +2 turns negative, and radius is square root of 25, which is 5. So we have 3, -2 is where we start by plotting, and then we go out 5 in all directions, up 5, left 5, down 5, and to the right 5. And we're going to make a nice big circle here. Try to make it as circular as possible. Don't make it square-like or diamond-like. Alright, then take a look at the next page so we can get some more practice with circles. Alright, so we're looking at the bottom of our paper here. It says, for each equation below, write the following equations in center radius form. Then identify the center and the radius and graph it. So you look at this equation and you're like, holy crap, what is that? X squared plus y squared plus 6x minus 8y plus 9 equals 0. What we're going to do is complete the square twice, once for x's and once for y's. So our first step is to group x's with x's, y's with y's, and move the constant term. So we have x squared plus 6x plus blank. Then we have y squared minus 8y plus blank. And we're moving this 9 to the other side by subtraction. So equals -9. Then we're going to get a plus blank for the x, plus blank for the y's. So like I said, we're going to do this twice. Once for x's, once for y's. So take your linear term for the x's, somewhere off to the side, divide it by 2, and then square. 6 divided by 2 is 3, 3 squared is 9. Whatever you do to one side, do it to the other. We're going to stick with x's for just a minute. We're going to carry it all the way through. So now we're going to add, multiply. Parentheses x, parentheses x. Two numbers that multiply to 9 and add to 6. We're adding to a positive 6, so they should both be positive. And then because I have x plus 3, that means I really have x plus 3, parentheses squared. So you can see that we're starting to get it into center radius form, where we have that x minus h squared plus y minus k squared equals r squared. Our next step is to figure out the plus blank for the y's. So take your linear term, the -8, cut it in half, and then square. negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. Whatever you do to one side, don't forget to do it to the other. So now we have add, multiply. We have a plus, parentheses, y, parentheses, y. Two numbers that add to negative 8 and multiply to 16. So I have minus 4, then condense, y minus 4, parentheses squared. And then on the right-hand side, we have negative 9 plus 16, which gives us 16. So here's our new equation of a circle. Our next step is to identify the center and the radius. Positive 3 turns to negative. Negative 4 turns to positive. And remember that we take the square root of the number on the very end, which gives us 4 for the radius. So we're going to start by plotting negative 3, positive 4. I'm going to see if I can just erase this stuff for now. So we have negative 3, positive 4. We're going out 4 in all directions. All right, there we go. Go ahead and flip it once you have it. Remember, if at any point in time you need to pause or rewind the video, please do so. Don't sit there going through the motions. It's not going to help you when you're ready for your assessment. If you want to practice the skill that we just did where we completed the square for these circle equations, feel free to do one of these problems, 23, 24, or 25. They're all great problems to practice, and when you're done, you could ask for the answer key so that you can check your answers. Okay, so now we're going to move away from circles for a few minutes. We're going to come back to them in just a couple minutes. And we're going to talk about these things called linear quadratic systems of equations. So a linear equation is a line, and a quadratic equation is a parabola. And it could be upwards or downwards facing. Same thing with the line. It could be positive or negative slope. So when we're solving linear quadratic systems, what we do is state the solutions, meaning where do they intersect each other? Where do they cross? And so what I like to do is circle the solutions, and then we state the coordinates in curly brackets off to the side. So for example, this first one is located at negative 1, 2, 3. So negative 3, comma, we're going up 1, 2, 3, 4, 5. Negative 3, comma, 5. Can you find the coordinates of the other one? Hopefully you found the same ones, 1, comma, negative 3. So what we're going to do next is solve a system both graphically and algebraically. And you have to be able to do both of them because your assessment will require that, just as the Common Core standards require that. So what we need to do is get the equations first in y equals. So the first one is okay, but the second one is not. So we're going to add x to both sides. So now we have y equals x minus 1. So when we're solving this graphically, all we do is type this first equation in the calculator and we graph it. We type the second equation in the calculator and then we graph it. And then we state the solutions, again, curly brackets and points of intersection. You could have 0 points of intersection, 1 point of intersection, or 2 points of intersection. There will never be 3 with a quadratic and linear system. So I'm going to have you type the first equation, the x squared plus 4x minus 5, into your calculator, and then we're going to start plotting some points. Pause the video while you're typing it in, and then come back to me as you start plotting or after you're done plotting to check your parabola to see if it matches mine. Okay, so the first one I have is negative 6, positive 7. Then from there we have negative 5, 0. After that we have negative 3, negative 8. or I'm sorry, negative 4, negative 1, 2, 3, 4, negative 4, negative 5. Then we have negative 3, negative 8, negative 2, negative 9, and then we start looping back upwards. So negative 1, negative 8, 0, negative 5, 1, 0, and 2, 7. Then once we have that, we're going to type the other equation, y equals x minus 1, into the calculator. And we're going to start plotting that as well. You could think about the fact that this has a y-intercept of negative 1, and the slope is 1 over 1. So I'm just rising and running 1 over 1 and plotting those points. Apparently I'm very bad at connecting them in a straight line. Let's see if I can do a better job. Alright, that looks better. Remember that solutions are where your two graphs cross. So I have one here and one here. We're going to state those solutions. We have negative 4, negative 5, and 1, 0. So in order to get full credit for the graphic solution, you have to have the graphs, and then you have to have your solution. If you need more time for plotting those points, remember that you can pause the video, rewind, do what you need to do to help yourself be successful. The next way that we're going to solve it is using an algebraic solution. So you still have to get both of them in y equals, and then once they're in y equals, remember if they're both equal to y, the same exact thing, then that means those expressions, x squared plus 4x minus 5, must be equal to x minus 1. Because they're both equal to y, they're both equal to the same thing, so they're equal to each other as well. So what we do is we solve this quadratic equation by setting it equal to 0, factoring using add, multiply, and then our little t-chart. Once we t-chart, we're going to have to go back and find the y values. Alright, so we're going to subtract x, we're going to add 1. Subtract x, add 1. So we have x squared plus 3x minus 4 equals 0. Then we're going to factor using add, multiply. So we have x, x, two numbers that multiply to 4 and add to 3. Because I'm adding to a positive 3, bigger number takes that sign, and subtract the 1. Now we're going to t-chart, where we set each factor equal to 0. You're going to solve both sides for x. Simple little solution here. So we have x equals 1, x equals negative 4. But remember I said once we t-chart, we still have to find the y values. So we have x equals 1, and we're going to plug it in to one of our two equations. Take the easier route, so we have x minus 1, but we replace x with a 1. Lots of 1's going on here. So we have y equals 1 minus 1, which is 0. So we plugged in 1, we got out 0. That becomes the coordinate point, 1, 0. Okay, the next one, we have x equals negative 4, so y equals negative 4 minus 1. Again, all I'm doing is plugging into this second equation that we had from way up top that we did at the beginning of this problem. So we have y equals negative 5. We plugged in negative 4, got out negative 5, so that gives us the coordinate point, negative 4, negative 5. Once you have your two coordinates, stick them in curly brackets, and you are good to go. The cool thing about this is that no matter which way you solve it, algebraic or graphic, you should get the same answer every time, because you're still solving the same problem. Alright, flip it over so we can get some more practice. Number 28, very similar. Remember, get it in y equals first. The first equation is just fine. We're going to leave it the way that it is. But the second equation needs to be divided by a negative 1. So divide out that negative that's in front of it. And we now have y equals negative divided by negative turns positive 2x, and then plus 3. So now we have our two equations. We're going to graph them both on the graph paper. So if you would type them both in your calculator, graph them on your own, and then replay the video when you're done so you can check your answer, that would be the best option for you so that you can do this independently, practice it a little bit because you will have a question like this on your assessment. Now I will go through the video without talking, using the strategies that we just talked about, typing them in the calculator. So if you want to follow along with me, that's fine. I'm just not going to be talking through it. However, you should try it on your own first. If you need more time, just pause the video. Otherwise, check your answers. You should have found -4, -5, and 2, 7. Now we're going to take a look at the algebraic solution. So remember that both equations need to be in y equals, and then we're going to set them equal to each other. So we have x squared plus 4x minus 5 equals 2x plus 3. Remember, first you're going to get it equal to 0, then you're going to factor by using add multiply, then you're going to t-chart and get the y's. Get y's. Alright, so I'm going to have you do this independently again. If you want, you can pause the video and then check back with me. I will continue doing it on the video, just silently. Okay, so if you need more time, pause the video, rewind, do what you need to do. I just did all of my algebraic solution following the steps that we had listed up above it, and I found that I still have -4, -5, and 2, 7 as my solutions. We still have a couple more things to talk about, so keep moving forward with me. We're going to now move into linear and circle equations and solutions and systems. Alright, so we got a couple questions here to take a look at. We have linear and circle systems of equations. Remember, with circles, we have to identify the center and the radius. So center and radius. Equations do, as far as the linear ones go, have to be in y equals, and then that way we can plot them along with the circle and see where they cross, where they intersect. So we have x squared plus y squared equals 16. There's nothing attached to the x's nor the y's, so this means that it's centered at the origin, 0, 0. Not sure what's going on with my pen. And the radius is the square root of 16. As we learned earlier, we have to take the square root of the value on the right side of the equal sign, which gives us 4. So we go starting at 0, 0 and out 4 in all directions. Okay, then from here we're going to graph y equals negative x plus 4. You can type it into your calculator if you choose to do so. That's fine. Just make sure that you pause the video while you do it because it will take you a little bit more time than it will for me. Once you have them graphed, circle your solutions and then state the coordinates. I have 0, 4 and 4, 0. Moving on to 33, remember if you need to pause it and stop so that you have time for yourself, that's fine. Just pick up where you left off by hitting play again. So the first one is a circle. The reason I know it's a circle is because there's an x quantity squared, there's a y quantity squared, and it's equal to some number, which is representing the radius squared. So we find the center by negating the value. Negative 3 negated now becomes positive. Positive 4 negated now becomes negative. And we have r equals square root 25, which is 5. So we start by going at 3, negative 4. And we go outwards 5. Then the second equation is not in y equals, so we have to subtract the 2, get it away from the y. So we have y equals x minus 2, and we're going to type this into the calculator. Go ahead and state your coordinates once you're done. I found 3, 1 and negative 2, negative 4. Go ahead and try 34 on your own. I will follow through on the video as well, but I'm going to do it silently. Remember that you should identify the center and the radius first before you plot that circle. If you need more time, just pause the video, My final answer is 5, 0, and 0, -5. So it looks like we made it through all the circled problems, but remember, if you feel as though you need more practice, there are plenty of questions in this review packet for you to go practice independently. You can also ask a teacher around you for help. When you're done with the practice, if you choose to do more on your own, then just ask for the answer key so you can check your answers. Otherwise, if you're ready, go ahead and take the assessment.